Hello, I want to do a new build video for Big Yarn. There was a competition 2 weeks ago, the Pit of Doom, and Big Yarn competed but it didn't win. It actually lost a couple of fights, so I want to fix up the mistakes from those losses. You can probably hear in the background the printer going. I'll show you. I've actually started making a new version of this robot already before I started the video. There we go. Now, I just want to go through the fights from the weekend so you can see how the robot lost and what mistakes we need to fix up. Okay, now the first fight was with Sir Flip-A-Lot, which is a hire robot. It's been driven by a guy I don't remember the name of, and it was his first time driving a robot, and it was actually a pretty good fight. Now, the only issue that I had in that fight was that the wedge at the front was higher than the wedge on Sir Flip-A-Lot, so he did get underneath of me. But because I've been driving a bit longer and had a bit more practice, I was actually able to, every time I noticed that I started going up on his wedge, I reversed and pulled off the wedge. So that went rather well, and I won that fight. There's the fight. You can see both robots are pretty well matched. Big Yarn does do a bit of a flip there. There we go. I was on the wedge and I backed off. And again, back on the wedge and backed off before he could flip me. So it's going pretty well for me. Anyway. And this is the final part of the fight, and I'm able to push him in the pit. Woohoo! Second fight was against one of Steve's little kit robots. Now those robots are actually pretty good and they tend to self-right rather easily, but during that particular fight the little flipping arm broke on it and I sort of just ended up pummeling it against the wall, and it was kind of a boring fight and an easy win. Okay, here Big Yarn pushes it and knocks it over, and you can see the flipping arm going up and down, but not enough power to self-right, and I just end up pushing him and pushing him. Couldn't actually free it from the wall, but just hitting it. The second fight was against Jules's new drum spinner called Ginger Baker. Now that was a good fight. The robot, Ginger Baker, did do some damage to the front of the robot. I'll see if you can see that, but at the front here it took a few chunks out of the wedge and nice big dent on the side here. But the new PLA Plus that I use to print these robots is pretty strong, and I'm quite happy that I don't need any steel on the front of the robot to protect it. So this is actually a pretty good spinner killer. It actually ended up knocking the axle out of Ginger Baker's drum, and the drum fell off and the robot went crazy and propped itself against the wall. So nice little spinner killer here. So you can see that Big Yarn takes quite a few hits here, and I'm not entirely sure which hit is the one that does the damage to the front, but actually takes quite a lot of hits. And this is where the drum goes a bit crazy and falls off. Now the third fight was against Slab Chin McChuckle. Now I'd already won 3 fights, so I was feeling pretty confident at this stage. But Slab Chin is extremely fast. It's just a wedge bot like this, so 4-wheel drive pushy bot, but I don't know what motors he had in there or if they're the same geared up, but it was so much faster than Big Yarn. The main difference though is if you increase your robot's speed up to that sort of thing, it's hard to control, whereas I kind of like the speed that Big Yarn's got at the moment. It's much easier to control, so I was able to manoeuvre around him quite well. But he did do one slam against the wall which flipped Big Yarn over. Now these make it easier to drive, but he managed to prop it up so it was sitting on the front of the wedge like this, and my lights just turned off. Cool. Anyway, but it was propped up on the wedge like this and I could not drive, which is a real pain. So that's one of the problems that I'm going to have to fix, is stop the robot from sitting on the wedge like this. So this is part of the fight where we're trying to push each other around. As you can see, I was always able to turn and face towards him whenever he charged me, so even though I'm not as fast as him, I was able to sort of outmaneuver. And this is where I get stacked. So he pushes me upside down, I try to get out away from the wall, and then it knocks it over onto the front of the wedge, and I can't do anything. Fight over. The final fight, which I also lost, was against Chuck Redux, so built by the same guy. Jeez. Jeez, I've forgotten his name. I'm going to get in so much trouble for that. Anyway, his robot, really good flipper, kept flipping Big Yarn over, but it did, with the casters on the front, it was able to drive rather well. It didn't get propped on the nose, which is good. The only problem is that even though it drives really well on these now, there's no way of attacking the other robot. There's no wedges under here and nothing out the back to attack with. So I need some way of being able to wedge the other guy when the robot's upside down. He was nice enough to keep flipping me back over onto the wheels, but I drove into the pit. So I guess that's another thing to fix. Stop driving into the pit. So here's the final fight of the day. As you can see, I do manage to push him around a bit, but he can flip me over. Now, I've got nothing I can do at the moment except hope that he tries to tip me back over. I tried to keep him in the centre of the arena so he wouldn't flip me over the edge. But, there's nothing I could do. I could try attacking with the back or the front. I tried the front because it seemed like the most easiest way for him to flip me back over. But that means technically I was driving backwards. And then when the pit finally opened, I thought I had my chance to push him down, but missed. Okay, so the two changes I want to make to this robot so it competes better next time is to add an extra little set of wedges so it wedges while it's upside down. Now I'm thinking that I probably should put the wedges out the back, because I've tried wedges out the front before on a featherweight Vendetta. I had these little spikes that came out the front. The problem is that when a robot hits it, when it hits the wedge, it lifts the nose up, and these wedges don't actually wedge. So I'm better off having them out the back here, and that way I can drive this way into the robots. And we all know when you're upside down, forwards and backwards gets reversed, so having them out the back also means that I don't have to think about it so much when I'm driving upside down. I'll have to put the wedges so they actually cover the wheels a bit. I might put them so they cover the gears, but I might leave the wheels still exposed a bit so it's still able to drive when it's like this. So yeah, we'll put a couple of little wedges out the front, and I also need to stop it sitting on the nose like this. Now the problem is the centre of gravity is somewhere in front of the top of the wedge here, and the immediate thing that the guys on the weekend were saying was that I probably have enough weight that I could put a servo in here as a self-riding arm. Now, I actually don't have that much weight. The last time I put this thing on the scales it was 138 grams, and the last time I checked a Metal Gear Servo was more than that. So I don't actually have enough weight to put a servo in here. And even if I did, I only have a 2-channel radio which can't control it anyway. So putting a servo-controlled thing on there to do it won't work. My other initial thought was to add something under the nose here so it rocks over, but if I put it in the centre, like about here, it doesn't work. So I need to put it off to the side so it rolls over like that. So as you can see, if I put something there, it rolls back onto its wheels. Main problem I thought with that is that I end up with one horn sticking out one side of the robot out here. Now that would look kind of stupid. It'll look like a lopsided unicorn really, and it also comes out the front where spinners will hit it. So the reason why I have such a big wedge here is to protect from spinners, and also to hit vertical spinners, and a vertical spinner will take a knob off the front pretty quickly. So I don't really like that idea. The next idea I had was to make the wedge hinged. Now this would also allow me to get under robots a little bit easier. But if I make it hinged and put the hinge point so that the centre of gravity, so it's behind the centre of gravity here, so the back of the robot falls down and it can still drive, we can use the front as a wedge while it's driving around. But that actually means that I'll create a hinge point somewhere which is kind of an extra fail point. And since I tend to print this way, there won't be the strongest hinge point in the world because it'll be on the delamination point of the print. So if I wanted it stronger, I need to print it this way, which is a bit of a harder print. So I'm sort of could do the hinged wedge, I sort of can't, but at the moment I'm leaning against it. So my other option is to move this point backwards so the centre of gravity is further out than this point. So that means that it's basically just making the front wedge smaller so that it'll tip over. Also, if I try to make sure that I mount the battery further back up the robot, it'll push the centre of gravity back and it'll tip back over like this anyway, and then I can use the rear wedges to wedge other guys. So that's the plan. Make the front wedge lower and the whole robot lower, and then wedges out the back. Okay, here's the current 3D model for Biggin. At the moment I'm just going to try to turn on the centre of gravity option in Inventor so we can see where the centre of gravity is currently sitting in the model. As you can see, it's pretty close to the front wheels when it's right way up. When it's upside down, you can see that it is closer to the bearings than the rear wheels, which is why we had trouble driving when it was upside down. And now when we put so it's orientated on the wedge, we can see that the centre of gravity is on the wedge side of the upper lip. This is why it balances on the wedge rather than falling back onto its wheels. So what we need to do is move that upper lip of the wedge further up to the left so that the centre of gravity will cause it to fall back down. Okay, the first thing I'm going to do is add in the little wedges on the back. So we'll draw those in so they fit around the top cover, making sure that they're constrained to the wheels so that the covers are centred on the wheels. There we go. So I'm going to put one on each side. I'm not going to do a full wedge across the back just to reduce weight, just two little prongs out the back. It's going to look a bit strange, but oh well. So there we go. Now we're just checking the centre of gravity to see if that's moved. Okay, this is the original vertical layout sketch where I position the wheels and the motors and everything. So this is just reducing 3 mil off the top of the robot, and then we update to see what happens. Now with the update there is a problem with the model, and I have to go back and try to figure out what went wrong. Turns out it's the little curve at the back that was stopping it from extruding. Okay, after an update you can see that the centre of gravity has moved slightly behind the pivot point, so we just fillet those out just to make sure it rolls over, and then finish the model off. This is a quick shot of the printer printing the chassis for the robot. And then we go to start assembling it. So these are all the parts that have been printed. And now we just need to strip down the old robot and put it into the new one. Put all the electronics in. It's a pretty quick process. Most of the parts just come straight out and there's not really much to the robot other than the wheels. Now I did have one problem when I was trying to reassemble it, and I discovered that the clearance between the new wedges on the back and the wheels was rather too small. So I actually made the wheels slightly smaller in order to get the in there to have a nice smooth fit and keep the robot running well. This doesn't actually affect the meshing of the gears any much because I didn't change the pitch of the gears. I just took a bit off the tip of the gears and it seemed to work pretty well. But putting the covers over the gears wasn't a good idea at all. Other than that, the robot printed and assembled rather easily. There was no problem with the printing at all. Everything came out smooth and the assembly went perfect. Considering it's the same model as before, I should expect it to be the same. Now I'm testing to see whether or not it drives upside down, and wheels do turn while it's upside down, and then we test the balancing point while it's on the wedge, and as you can see it tips over quite easily. So that all worked pretty well. And now a quick drive test to see how it goes, and yeah, it drives the same as it did before. The ground's a bit rough here, so it does drive a little bit slower than on the wood of the arena. However, upside down it does have drive issues, so it drives wedge first pretty well, which is the same as before, so driving on the bearings works pretty well. But when I try to go into reverse, the robot does not drive straight and it tends to do these little spins a lot. Now this is because technically the wheels are a lot further in front of the centre of gravity, and robots with the drive wheels that far in front do not drive at all well. As you can see, I'm stuck over the edge here and I can't escape. So the wedges on the back of the robot to wedge people when I'm upside down does not work, and I should not have done this. In hindsight, I probably should have gone with the hinged wedge and attacked the other way with the weighty section at the front of in front of the wheels. So that'll be the next revision of the robot. So I'll have to redo it with the hinged wedge and delete the wedges off the back of the robot to make it drive well upside down.